The flight facility was stood up in the 1950s. Over those years, we have changed and developed airplanes in order to meet user needs, program needs, laboratory needs, and looking future-wise, not just to have a platform for an immediate use, but looking for a platform that will continue from today through the next 10 or 20 years. We have gone from the early days to a wide variety of aircraft to support a wide variety of needs. Going from largest to smallest, we have a Boeing 707, which has been around since the early 2000s for the laboratory, and unfortunately is getting ready to finish up its life here and its programs here. We have a couple G4s. We have a G2. We have an HU-25. We have 2 Twin Otters right now. We lease the Twin Otters. They are such a capable platform. They're an inexpensive platform for our user groups to use if that meets their needs. We always have at least one on hand. And then we have a Cessna 206. That's a single engine, low slow platform, which is also inexpensive. And so they tend to like to use that one as well if it meets their program needs. Recently, we've had a couple of programs that have started on our Twin Otters and realized that those aircraft don't meet the needs for what they need, and working with the program and figuring out a solution long-term that allows us more flexibility for them, but also more flexibility for other programs to follow. We have a Saab 340 getting ready to hit our ramp about mid-October. We're a 145 repair station, which also allows us a lot of capability in the modifications that we do with our airplanes. All of our airplanes maintain an experimental certificate, so that allows us to be able to do a lot of these modifications, and we can do a lot of them in-house across multiple different platforms. We've been able to do ball turrets with EO, IR. We've been able to put on large radar arrays. We have a platform that was developed and named pretty much shortly after Hurricane Harvey, around that time frame of 2017, the airborne radar testbed that has been used for multiple different programs, all on a radar type mission, if you will, for data collection. It has had multiple large arrays down one side, down both sides. We've been able to put on cheek radomes and modify noses of airplanes and put things on the top, things on the bottom. And then we in-house have the ability to flight test those to figure out where the handling qualities are. Does it impact any of the flight characteristics? The FAA trusts that process, which has helped us be able to do some of these modifications, and then we bring them in. They tend to be very happy with what we do because of the care and the detail and the engineering that goes back behind any of our modifications. We can modify the internals with whatever the user needs in order to pull the data from those external modifications into the internal. We have a lot of capability, and again, it speaks highly to our engineering, development, design, our maintenance guys, and the whole process that we go through, that full flight test process and design that happens here. We can modify these airplanes, we can meet user needs, but flying an airplane, we just can't hover it over the ground. So we actually have to go out and we have to operate these aircraft in a variety of different places. It's great around New England because we have a variety of terrain, from mountains to ocean to wave characteristics to you name it. We have sites around the flight facility as well as at the main laboratory that have ground stations set up. Right now, we operate over Hanscom, down over the Cape. We go up north around Maine and off the coast. There's a couple of the whiskey areas that we use to be able to do some offshore type stuff. We can get things done efficiently without having to spend days going out west or going to the West Coast or going to down south to Florida, that we could do right here.